Hello everyone, in this video we will learn about the special series and their sum to n terms. Before we go to some of the special series, we should learn three special series of sum of natural numbers. That is, the first one is sum of first n natural numbers. That is 1 plus 2 plus 3 plus so on up to n. We represent this by sigma n from n is equal to 1 to n, or we write it simply as sigma n only. How to find out the sum? Say it is an AP where we find A is 1 and D is also 1. The last term L is given as n. So we can find out the sum of these natural numbers, this AP, by using the formula S is equal to n by 2 into A plus L. This implies that sigma n will be equal to n by 2 into A is 1, L is n. This comes as n into n plus 1 by 2. So we can remember here that sum of the first n natural numbers, that is 1 plus 2 plus 3 up to n, is represented by sigma n, and the formula of that is n into n plus 1 by 2. The second series, in case of natural numbers, we have the sum of squares of first n natural numbers, that is sum of squares of first n natural numbers, that we know is 1 square plus 2 square plus 3 square plus n square, and this is represented by sigma n square when n is from 1 to n. We can also represent it simply by sigma n square. How to find out the sum of this? Here we have to use one of the identity, that is, if we have n cube minus n minus 1 cube, that we know is n cube minus the whole cube of a minus b. We apply here, that is n cube minus 3n square plus 3n minus 1. Simplifying this, we get n cube minus n cube plus 3n square minus 3n plus 1. N cube and n cube cancel. So this comes as 3n square minus 3n plus 1. So we write here, this is n cube minus n minus 1 whole cube is 3n square minus 3n plus 1. So we got the relation n cube minus n minus 1 whole cube equal to 3n square minus 3n plus 1. If we substitute the value of n as 1, 2, 3 up to n here, let's see what happens. Substituting n is equal to 1, 2, 3 and so on up to n. When we substitute 1, we get here 1 cube minus 0 cube equal to 3 into 1 square minus 3 into 1 plus 1. When we substitute 2, we get 2 cube minus 2 minus 1 is 1 minus 1 cube 3 into 2 square minus 3 into 2 plus 1. When we substitute 3, it is 3 cube minus 2 cube equal to 3 into 3 square minus 3 into 3 plus 1. And so on, we substitute n, then it comes as n cube minus n minus 1 whole cube equal to 3 into n square minus 3 into n plus 1. Now if we add them column wise, we find here 1 cube cancels, 2 cube cancels, and so on, all the terms will be cancelled till here, and we will be left with here n cube minus 0 cube, that is n cube. Here if we add them column wise, we are getting 3 common in the first column, and this comes as 1 square plus 2 square plus 3 square up to n square. minus, when we take 3 common from this comes as 1 plus 2 plus 3 plus so on up to n. And here it is 1 plus 1 plus 1, n times when we add it becomes 1. Now we know this is sigma n square, so we write 3 into sigma n square. This is sigma n, so minus 3 into sigma n plus n. If we transpose the terms, we will be getting here 3 into sigma n square is equal to n cube plus 3 into sigma n minus n. We know the value of sigma n, so we substitute here n cube plus 3 into the value is n into n plus 1 by 2 minus n. If we take n common and 2 as LCM, this will be n by 2 and here it will become 2n square plus 3 into n plus 1 minus 2. When we simplify this is n by 2 into 2n square plus 3n plus 1. We know we can apply the split method to find the factors of it. And the factors of this will be n plus 1 into 2n plus 1. Transposing 3 onto this side, we will be getting sigma n square is equal to n by 6 into n plus 1 into 2n plus 1. So we can remember this as sum of the squares of first n natural numbers, that is given by n upon 6 into n plus 1 into 2n plus 1. The third series, for the natural numbers we have the sum of cubes of first n natural numbers. Sum of cubes of n natural numbers. That is 1 cube plus 2 cube plus 3 cube plus so on up to n cube. This is represented by sigma n cube when n is from 1 to n. Or we can also write this as sigma n cube only. Sigma n cube means sum of cubes of first n natural numbers. To find the sum, here also we have to use one of the identity, that is we can write n power 4 minus n minus 1 power 4. When we simplify this, we are getting n power 4 and it is here n power 4 minus 4n cube plus 6n square minus 4n plus 1. Simplifying this, we get n power 4 minus n4 plus 4n cube minus 6n square plus 4n minus 1. These terms cancel and we are left with 4n cube minus 6n square plus 4n minus 1. Now as we have done there, we can write this relation n power 4 minus n minus 1 power 4 equal to 4n cube minus 6n square plus 4n minus 1. Similarly, as we have done in the previous one, that is the sum of squares, we can substitute here 1, 2, 3, 4 and all, substituting n is equal to 1, 2, 3, 4 and so on up to n, and adding column wise, we will be getting here n power 4 is equal to 4 into sigma n cube minus 6 into sigma n square plus 4 into sigma n minus n. It means we can find sigma n cube as n power 4 plus 6 sigma n square minus 4 sigma n plus n divided by 4. And this, when we simplify, substituting these values, we are getting this as n into n plus 1 upon 2 whole square. We know that this is sigma n, so we can write this as square of sigma n. It means we are getting the sum of cubes of first n natural numbers, that is sigma n cube, as n into n plus 1 by 2 whole square. And also we can find a relation between sigma n cube and sigma n, that sigma n cube is same as square of sigma n. Now to find the sum of n terms of a series given to us which is based on the natural numbers, we can apply sigma n square, sigma n cube. What is the algorithm to find the sum? The first one is, for the given series we will find out its nth term. So find the nth term of the given series. Second point is, we can express this nth term as the polynomial of n. So we can write express the nth term as the polynomial of n. That is, we can write an is equal to a into n cube plus b into n square plus c into n plus d. And the third step is to find the sum. We will use sigma here. So we can write find the sum as s is equal to a into sigma n cube, b into sigma n square, c into sigma n plus d into n. Because when we are adding the constant n times, that will be that constant into n. Like this we can find out the sum of any of the series which is given based on natural numbers. We discussed some examples based on the concept which we have learnt just now. So the first one here is, find the sum to n terms of the series 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus so on. To solve this problem, according to the algorithm, first we have to find out its nth term. We write the series 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus so on. We can see here easily the nth term will contain n terms of this. It means that will be 1 plus 2 plus 3 plus so on up to n. And we can see here this is the sum of first n natural numbers, which is equal to sigma n. And we know it is n into n plus 1 by 2. Can we write this as 1 by 2 n square plus n? So the second step we have taken, we have expressed nth term in terms of the polynomial of n. And now to find out the sum, we can write here 1 by 2 sigma n square plus sigma n. This is the third step. Now we will substitute the values of them, that is 1 by 2 sigma n square we know is n into n plus 1 into 2n plus 1 divided by 6. We know sigma n is n into n plus 1 by 2. We are getting n into n plus 1 by 2 as common, and if we take 6 as LCM, this will come as 1 by 2 n into n plus 1 by 6 here. And in this we will have this as 2n plus 1 plus 3 into 1. When we simplify this, this comes as n into n plus 1 upon 12 into 2n plus 4. If we take 2 common from this is n into n plus 1 into 2 into n plus 2 divided by 12. This 2 cancels this 6 times. So we are getting here n into n plus 1 into n plus 2 by 6. This is the sum of n terms of the given series. Sometimes we get a series based on natural numbers to find the sum of n terms, but we find neither it is an AP nor a GP. We find here that the difference between the terms is increasing. What we do in such cases? We use a particular method here to find the nth term of such series, that is known as difference method. We will understand this method by taking one example, and it is here: find the sum to n terms of the series 3 plus 6 plus 11 plus 18. To find the solution, we write the series first and see 3 plus 6 plus 11 plus 18 plus so on. We are finding the difference. Here is 3, here 5, here 7 and so on. It is increasing. In such case, we apply the difference method to find the nth term. So we can write, let the nth term be an. Let the nth term of the series be an. Then suppose the sum of n terms is given by s, that s will be 3 plus 6 plus 11 plus 18 plus so on, and last is an. We write the same s again, but we are replacing the first term to the second place, second term to the third place, and so on. We are proceeding one term ahead. We can write this as 3 plus 6 plus 11 plus so on, and we will find here this will be n minus 1th term, and the nth term will go one step ahead. When we find the difference between them, subtracting, we are getting here this is 0. Here we find this is 3. This will come 6 minus 3, 3, 11 minus 6, 5, 18 minus 11, 7, and up to here we have n terms. And this nth term is the extra one. What we see, if we transpose this an, we are getting an as 3 plus 3 plus 5 plus 7, so on, n terms. We can see still it is not an AP, but if we separate this first term, we are finding this is an AP 3 plus 5 plus 7, but here we will have only n minus 1 terms because one term is here. And we know how to find out the sum of AP. That is, we can apply the formula S is equal to n by 2 into 2a plus n minus 1 into d. Applying that formula here, we get n minus 1 by 2. 2a means 2 into 3 plus n minus 1 means n minus 1 minus 1, that will be n minus 2 into d, and d here is 2. If we take 2 common, it will be 3 plus n minus 1 by 2 into 2, and here it will be 3 plus n minus 2. 2 and 2 cancel, and it comes as 3 plus n minus 1 into n plus 1, which is equal to 3 plus n square minus 1, or we can write this as n square plus 2. Now to find out the sum of n terms, we can apply this polynomial and use sigma. So we find here the sum here will be sigma n square plus 2 into n constant multiplied by n. So we are getting here the sum as sigma n square plus 2n. We know the formula of sigma n square, that is n into n plus 1 into 2n plus 1 upon 6 plus 2n. Taking n by 6 as common, we get here n plus 1 into 2n plus 1 plus 12. When we simplify, it comes as n by 6. This is 2n square plus 3n plus 1 plus 12, which is equal to n by 6 into 2n square plus 3n plus 13. This is the sum. So like this, we can find out the sum of n terms of such type of series by applying the difference method. In the next video, we will learn about harmonic progressions, its nth term and the harmonic mean. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.